How do you structure a module inside of a modular monolith architecture? Should you be using a layered architecture, clean architecture, or perhaps vertical slices? And what if you could be using all three of those inside of the modular monolith? That's what we're going to discuss in today's video, so let's dive in. We are continuing our exploration of the modular monolith architecture, and in this video I want to focus on the module architecture, and the angle that I want to explore is that you should treat each module like a separate application inside of the larger modular monolith system. What this means in practice is that you can apply various architectural styles to your individual modules inside of the modular monolith. For example, you could be using the N-tier architecture inside of one module, where we have an API project with controllers, a business project implementing the use cases of the module, and then the data project containing the EF core database context and your domain entities. A typical implementation of this architectural style would mean that we have anemic domain models and we use the transaction script pattern to implement our business logic. An alternative, and something that I like to use, is to implement the clean architecture for the individual modules. So you end up having multiple clean architecture implementations for the individual modules in the system. If you are following a domain-centric design, this kind of architecture fits very nicely inside of a modular monolith, and it's something I've used in production many times with a lot of success. One more alternative you could explore is using the vertical slice architecture for your modules. With this architectural style, you organize your application around features or use cases, and the overall architecture of such modules would be a flat structure where you group the use cases into folders. Now, in practice, nothing is stopping you from using all three of these architectural styles in the same application. So one module could be using a layered architecture, and then another module could be using the clean architecture, and another module could be using vertical slices. All of these architectural styles are a means to an end, and they allow you to organize your code in a structured manner that you can continue to evolve over time. And of course, each of these architectural styles also bring their own qualities to the table, but that's not the topic of today's discussion. Let's look at a concrete example of module architecture. Here I have a very simple modular monolith that only contains two modules. We have the users module and the training module. Now, these modules are currently incomplete. They only contain the domain project with the domain entities and any abstractions, and the application project with the use cases. You can see that both modules are following a similar domain-centric architecture, and what's missing is the concrete implementations that are currently inside of the infrastructure project. For example, the database context and any external services. But I first want to focus on the training module, and I picked the create workout use case for what I want to show you. And what you can see here is that we have a reference to the users module, and the complete namespace is actually the domain project with the users aggregate. This is because I'm referencing the user repository and the user entity inside of my training module. This is something that I don't want to do, because now I have access to the user entity and any methods or behavior that's exposed on this entity. The reason we have this reference is so that we can check if the user with a specific identifier exists in the database. And if we want to implement this in such a way that allows us to remove the dependency on the domain project in the users module, we would have to come up with a better solution. And how modular monoliths solve this is by introducing the concept of a public API. So I'm going to add another project into the users module, and it's just going to be a class library. Let's give it the name of modules users, and I'm going to add API. So this will represent the public API of the users module. Let's go ahead and create this project, and I'm going to replace this default class with a public interface. Let's call this the iUsers API. What we are going to do is to reference this abstraction, the iUsers API, to check if the user exists or not. So let me adjust the name of this file, and then I'm going to expose a method that should return some sort of user response contract, which I don't have yet. So let's go ahead and define this as a simple record. Let's call it user response. And I want to expose just two properties on this object. One is going to be the user ID, and for example, we can expose the user's name. Then let's call this method getAsync, and the argument is going to be a GUID value. We can also support cancellation if we want to, so let's add a cancellation token as a default argument. Now I'm going to move these types into separate files, and then I'm going to go back to my training module, and let's remove the project reference to the modules users domain project, and let's introduce a reference to the modules users API project. This is going to cause some compile errors because we can no longer see the iUser repository, so let's replace this with the iUsers API. I'm also going to appropriately rename this to be users API, and now let's call the getAsync method to get back a user response. If I update the type information here, you can see that we are getting a user response, and we should make our interface more honest. So I'm going to update it to return a nullable user response, and the logic inside of my use case remains unchanged. Now, what do we do about the error for the missing user? If I navigate to the user errors class, it's defined inside of the domain project, and the not found error tells me that a user with a specific identifier is not found. So how are we going to solve this? I don't want to be referencing this type from my users module in the training module, so I could either introduce a different error type, or I can live with some duplication and define this specific error in the training module. So let's say I go down this route. I'm going to grab the user errors object from my domain layer, and I'm going to copy it into the training module in the domain layer. Let's define a users folder in here, and I'm going to paste the user errors inside. I'm only going to leave the not found error, but I'm going to be updating the namespace. So this is now the training module, and then we have the rest of the namespace. And now if I go back to my use case, I'm going to import the user errors object from the training module. And you can see that the only thing that I'm referencing from the users module is just the public API. Let's go ahead and make this update in the second use case that I have, which is the use case for creating an activity. I'm going to add a using statement for the user errors, and for the iUser repository, I'm going to replace this with the iUsers API. I'm going to use this to fetch the user by the ID, but this is actually the user response type. So this is how our module architecture begins to take shape. I have the domain project in the training module, and then the application project containing the use cases. The users module has already evolved to contain the public API, and right now the public API is very simple. It only has one method to get the user information based on the user identifier. The implementation of this interface is going to live in the respective infrastructure project, so let me go ahead and introduce that. I'm going to add a new project in the users module, and let's call it modules users infrastructure. I'm going to create this project, and let's get rid of this default class, and I'm going to create a users folder where I'm going to implement infrastructural concerns related to users, and one of those is the users API type. So let's go ahead and create the users API class, and this type can be internal and sealed, and we are going to implement the iUsers API project. Right now I don't have a reference to this project, so let's go ahead and add that. I'm looking for modules users API, and now I can add a using statement for my interface. And now all that's left is to implement the getAsync method, and a real quick implementation just to show you could be injecting the iUser repository. Now I also don't have a reference to this, so I'm going to add a reference to the application project, which is going to give me a transitive dependency to domain. Of course, I'm going to be referencing the users application project. I'm going to add a using statement for the user repository, and then in the implementation, let's just do something simple like calling the user repository get by ID async. I can pass in the ID and the cancellation token. We get back a nullable user object, and let's just return if the user is null. We're going to return a null value. Otherwise, we're going to return a new user response, and we're going to set the user ID and the user name. Because the username is a value object, I have to access the value property. So this would be a simple implementation. You don't have to use the repository if you don't want to. We could have referenced the database context. Right now, the database context is living in the shared infrastructure project, and you can see it here, and this would be the next step in our module implementation. So I'm going to introduce a database folder inside of the infrastructure project in the users module, and let's add a copy to our application database context. This is not going to compile because I don't have a reference to EF core, but what I'm going to do is to reference the infrastructure project, which will also give me access to any NuGet packages that I have inside. So now my database context should compile, and I'm going to rename this into the users database context to make it obvious that this context is specific for the users module. Let's also update the file name, and you can see that I now have a database context with the users and followers entities, which means that now I can use this database context in my users API. So now this could become an injection of the users database context, and this entire method can be await context, and then we can access the users database set, and I can say select, and we can grab the user entity and project it into a user response. So we want to get the ID and the name value. We also want to filter by this object, but let's just call first or default async, and we want to fetch the user where the user ID is equal to the ID argument. So you saw what the implementation looked like with a repository, and this is what it would look like with a database context. From the perspective of the training module, it doesn't really matter if you are using a repository or a database context specific to the calling module. It only cares about interacting with the public API, which reminds me to update the namespace of my database context. If we continue going down this route, we're going to also introduce a database context in the training module that's going to contain the respective entities for that module. Then we can start talking about data isolation, and our module architecture begins to take shape. If you missed the previous video in this series about how you should split the monolith into modules, then you should watch this video next. Make sure to smash the like and subscribe buttons under this video, and until next time, stay awesome.